You ever seen a picture of a cow that looks like it spends more time in the gym than you do? I mean, we're talking full-on bodybuilder level muscle. It's wild, right? It almost doesn't look real. Well, today, we're going to pull back the curtain on the single genetic switch that makes these Hulk cows possible. Let's dive in.
Just think about that for a second. For pretty much every living thing, there's an internal off switch that kicks in and says, all right, you're big enough. But what if that switch was broken? What would happen if the signal that's supposed to tell muscles, okay, that's enough, time to stop, just never ever arrived? That's the exact question we're digging into.
And it all starts with this absolutely incredible animal. Yeah, this isn't science fiction, it's a real thing. In breeds like the Belgian Blue, there's this natural genetic quirk that gives them this double-muscled look. They're just incredibly ripped, packing on tons of lean muscle instead of fat. So how on earth does that happen? Well, to really get it, we first need to do a super quick review of how muscles normally grow.
So let's hit pause and do a quick primer on the basic biology of how an animal gets bigger. It's actually pretty straightforward.
You know, muscle growth really boils down to two main ideas. Early on, before birth, it's mostly something called hyperplasia. The body is busy making more muscle cells, creating the building blocks. Then after birth, the game changes to hypertrophy, which is all about making those existing cells bigger. So you make the fibers first, and then you bulk them up.
And this chart shows that journey perfectly. See? It's not just a straight line up. For most animals, growth explodes when they're young, hits a peak speed, and then naturally slows down as they get to their full, mature size. It's a very controlled, very regulated process. Or at least, it's supposed to be. For our Hulk cows, that whole system has gone completely off the rails. So, what is that control system? What's putting on the brakes? Turns out it's one single, incredibly powerful gene. Everybody meet myostatin. Honestly, the best way to think about this is to imagine muscle growth as a car that's speeding up. Myostatin is the brake pedal. Its entire job is to be a negative regulator, basically to tell the muscles, okay, fellas, that's enough, time to start growing. It's the body's built-in safety measure to prevent muscle growth from just going on forever. Okay, so what happens if you cut the brakes?
Well, this is exactly what's going on in those double-muscled cows. A natural mutation just completely deactivates the myostatin gene. The brake pedal is broken, it's on the floor, and muscle growth just goes into overdrive. You get both more muscle fibers than usual, that's the hyperplasia, and those fibers get way bigger, that's the hypertrophy. The result? A massive increase in lean meat and almost no body fat. But, and this is a big but, there is a serious downside. These incredibly bulky calves can cause major, sometimes even life-threatening problems during birth. And wow, the visual difference is it's stunning. On the left, you've got your typical zebu cow, and on the right, a crossbreed that's been specifically selected for that muscular build. Now, this isn't a direct myostatin knockout, but it's a perfect illustration of the genetic potential for muscle that we've been able to tap into through breeding. And that myostatin mutation is the most extreme version of this.
So this natural genetic quirk didn't just give us super buff cows. It also opened the door to a much bigger conversation. What are all the other ways we can influence and, well, hack animal growth? Right, so the myostatin gene is nature's version of this. But we humans have developed a whole toolkit of our own to tweak animal growth. We're talking everything from hormonal implants, anabolic steroids to boost growth rates, to modern biotech that lets us create synthetic growth hormones. There are even things like probiotics that help an animal just get more out of its food naturally. But actually using this science is, well, it's complicated. Take something like a synthetic growth hormone, RBST. Here in the US, it's approved to help cows produce more milk, but it's totally banned in the European Union, in Canada, and other places. This kind of split really throws a spotlight on a major global debate about what's okay to use in our food system and who gets to make that call. And that really brings us to the final big question here. From a single random mutation in one gene to incredibly precise biotechnology, we are getting unbelievably good at controlling the basic building blocks of life. Myos didn't show us what's possible, what nature can do by accident, but it also forces us to ask a tough question. Just because we can rewrite an animal's genetic blueprint, should we? And where do we draw that line? There's definitely no easy answer to that one.